My name is Scott, and we're going to solve the asteroid collision problem on LeetCode today. Let's talk about the problem definition. We're given an array asteroids of integers representing asteroids in a row. Each asteroid, the absolute value represents the size, and its sign represents its direction. Positive, it moves to the right; negative, to the left. Each asteroid moves at the same speed. Find out the state of asteroids after all collisions. If two meet, the smaller one explodes. If they're the same size, they both explode. Two asteroids moving in the same direction never meet. This is a fun little problem which we will solve using a stack approach. Let's run through an example or two. Here's the asteroids. So asteroid of size 5, of size 10, of size -5. These two asteroids, since they're positive, are moving to the right. This one, since it's negative, is moving to the left. These two asteroids will never meet because they are both moving to the right. So what's the first collision? Well, 10 is moving to the right, -5 is moving to the left. These two collide. 10 wins. 10 continues. 10 does not decrease by 5, it just remains 10. -5 just goes away. And then since these two never meet, we're left with 5 and 10. 8, -8. So two asteroids of the same size heading towards each other are going to collide. They both explode. We're left with nothing. Asteroids 10 to -5. These two going to the right, this one to the left. 2, -5 are going to collide. -5 is going to win. And then -5 will keep moving to the left where it will collide with 10. 10 will win. We're only left with 10. And then this one, -2, -1, 1, 2. So these two both moving to the left. These two moving to the right. None of these collide. Moves to the left, moves to the left. These are both moving to the left at the same speed, so they'll never meet up. 1 and 2 both moving to the right at the same speed. Never meet up, never collide. We're left with the exact same asteroid array as output. So, implementation. We're going to use a stack. So, let's set up our stack. I'm going to call it remains. Kind of a representation of the remaining asteroids after some collisions. And we are going to loop through the input asteroids array. And we're going to prostrate, that's not a word. We're going to process each asteroid. And the decision we're going to make for each asteroid is it moving left or is it moving right? So if asteroids of I, so the current asteroid that we are processing, it's less than 0. So in this block, it is moving to the left. What we're going to do when it's moving to the left is consider what it could collide with. So if the remains is empty, so we have no asteroids currently, or the element at the top of the remain stack is less than 0, then we are going to push onto the remains asteroids of I. What this little block of code basically represents is this asteroid is moving to the left, and every asteroid that we have processed so far is also moving to the left, or there are none left. So if there are none left, or all the asteroids we have in our stack are all moving to the left as well, then this is not going to collide with anything. So we just push it onto the stack. Otherwise, that's not the case. While the remains is not empty, and the element at the top of the stack is greater than 0, signifying that the element at the top of the stack is moving to the right, and the absolute value of the asteroid that we're currently processing is greater than the value at the top of the stack. What will we do in this case? Well, what this signifies is we have elements in our stack. The element is greater than 0, meaning it's moving to the right, and the absolute value of the left moving asteroid that we're processing right now is greater than the asteroid moving to the right. What does that mean? That means the asteroid moving to the right is going to explode. And we will signify that with remains pop by taking it off the stack. So that right moving asteroid explodes and we don't worry about it anymore. All gone. Now down here, if remains is not empty and remains peak equals math abs of the current asteroid we're processing. Okay, so what does this block represent? Well, notice we only looked for greater than here. We weren't thinking about equals. So if we get down here and we have encountered an asteroid which is equal to us, then what does that mean? Well, when it's equal, they both explode. Okay? So they both explode, which means we will just pop and continue. Now, why didn't we do this remains pop up here just like this? Well, if we would have added the equal here, then we may have exploded multiple asteroids of our same size. It doesn't work that way. They both explode, so only one of them explodes. So I'll pop it off down here. And then down here, we're going to actually check if remains actually is empty, or the element at the top of the stack is less than 0. In that case, we will just push it. So what does this case represent? This means that we have exploded all the asteroids, all the right moving asteroids that were in our way have been exploded, and we only have either no asteroids or only left moving asteroids, which means this current asteroid, left moving asteroid we are processing, gets pushed onto the stack. So that is it for the left moving asteroids. Again, so if we have a left moving asteroid, if we have no asteroids in the stack or the one on the top is less than 0, we push it onto the stack. Else, meaning we have a right moving asteroid, we blow up all the right moving asteroids in our way that are less than us. If we found one that's equal, we also explode that, but then we continue so we don't do anything else. And then down here, if we are empty again, and if we are either empty or the top element is also moving left, we push it on because it will not encounter anything that will explode it from there on out. So that is it for left moving asteroids. Let's deal with right moving asteroids, which is going to be really simple. Just push it on the stack. And why are we doing that? Because we're doing all the explosion, who wins, who loses calculations here on the left ones. And since we're going from left to right, if we encounter a right moving asteroid, we can just consider the left moving asteroid that comes after it in the array. Since we're moving from left to right, asteroid is also moving from left to right. So that's it for our loop. All that's left to do now is set up some sort of a return value. Because we were supposed to return a integer array, our elements are currently in the stack. This is all pretty boring. We're just getting the elements out of the stack and putting them in the array. while our remains is not empty. Just filling up our return array. And that should do it. Let's see how many syntax errors we ended up with. There's got to be a few of them in there. No, doesn't look like it. 510 is the right answer. Submit the solution. And we got an accepted solution. Cool. So, takeaway from there, this is just some special processing from the problem definition. Whenever you're faced with a problem like this, a lot of times a stack is going to help. If you're processing things moving from one side of the array to the other, things like that. If you start thinking, you know, I need to know what happened most recently, right? Because a stack is last in, first out. So when we look at this problem and we encounter a left moving asteroid, I don't need to know 5, I need to know 10. I need to know what's been pushed onto the stack. So when you see a problem and you say, hey, I need to know what I've seen most recently, start thinking you're going to use a stack. That is all for this video. Thank you, and we will see you next time.